Okay, moving on from here, we have to make a call to G. So now we're going to have G on our stack, so we have to create a new activation record for that. So our return address is the line that called G, so that is line 26. We'll need a dynamic and a static link. So the dynamic link is always the function that called us, and in this case that is I suppose I shouldn't have said function there. It's whatever called us, whether it is a function or just a generic procedure, subprogram, whatever called us. The static link is the enclosing scope. So the enclosing scope for G is A. So it just so happens that in this case, A is the thing that called us, and so these have the same static and dynamic links. Looking ahead, we can see that G is going to call F, and so and then eventually F is going to call F, and so we're going to see something that's a little more interesting than what we're seeing here. Thus far, the static and dynamic links have always been the same. That will not be the case in all of these, or for the course of the whole example. Okay, so we've got static and dynamic links. We need a space for a return value because G has a return value, so we need a space for that. Incidentally, if this is bothering you a little bit coming from 261, that's fine. In x86, we remember that we do our return value using the RAX register rather than pushing it onto the stack. So. All right, so we've got our return value slot. We have any parameters to G, and we do have one parameter. We have a parameter called X. And notice that we're passing in C, and notice that this is a reference parameter. And if you read the description of the problem, you'll notice that that's what this keyword means. And so what this means in terms of our diagram is that X is really just a reference down, and I'm going to draw this with a pointed line to distinguish it from the links. So this is really just a pointer to C. So wherever we're using X inside of G, we really need to be using C. Okay, and then we also have one local variable. So we have local R, and we haven't set that yet. So this is G's activation record, and we'll go over here and move everything around. So this is now our base pointer or our environment pointer, and this is the stack pointer up there at the top. Okay, cool. So now we're in G. So what do? Well, we decrement X, so remember that X here is really just a reference to C, so this really just decrements C, so C is now 1. And then it calls F. So we call F, and then we're going to need the return value of that and add it. So we'll need to do a little bit more here, but we can go ahead and make that call to F. So we're going to need an activation record for F. So we're going to need a return address. So we'll be returning to this line, which is line 19. We need a static and a dynamic link. So the dynamic link is always the thing that called you. So in this case, it was G that called F. But the static link in this case, so F is enclosed lexicographically in A. So that means that the static link is now going to point down to, and I got to get my lines set up right. So the static link is going to go down to A's activation record. Okay, cool. We need a space for a return value because F is a function. We have one parameter, which is X, and this is not a reference parameter, so that means that we copy whatever is being passed in here. So it's X, which is currently valued at 1. So that's our parameter value. And then we'll have a local variable r. So this is our stack frame for f. And if you look ahead a little bit, you'll realize that this is really just the stack frame for the first call to f, because we're going to call it again down here. So we set b equals 5. There is no b in f, so we have to go looking for it. This is, again, static scoping, so we follow the static link, and that gets us down to a, where we do have a b that we can set to 5. So that's good. And then we get to this where, so if x is greater than 0, well, x is not greater than 0, or x is greater than 0, sorry. So we will take this first branch where we need to make another call to f. And so we're going to need another stack frame. Our return address here is going to be wherever we called it, which is going to be line 10. We are going to need, again, dynamic and static links. Incidentally, you may be wondering about the dynamic links at this point. This is a statically scoped language, so we don't actually use the dynamic links. But we were told that the activation records for this particular architecture include them, so presumably maybe there are other languages that would compile down to use them. So we will be drawing them. So this instance of f was called by the first call to f, and so that's where the dynamic link goes. But again, the static link still points all the way down to a, which is what it is enclosed in. So we need another slot for the return value, and then the parameter. So just like before, we have the parameter x. And so we're calling it with x minus 1. So x is currently 1, so 1 minus 1 is 0. So that's the new parameter x. And then we have a local variable r. And this is the stack frame for our second call to f. It should be pretty clear here that b equal to 5 doesn't actually change anything because it's the same b that we changed the first time. But now x is 0, so we get to this second line here. And so the answer to the second question is this diagram. So this is, so I'll sort of scroll through it slowly here so that you can see it. But this whole thing here, oh, and I've been forgetting, like I said I would, I have been forgetting to update all the pointers. So at this point, the base pointer or the environment pointer is pointing here, and the stack pointer, sorry, is pointing up there. So yes, so this is the answer to problem 2.